So it says, can you get a pair of aces or 5 cards total, 2 aces, 3 kings, 2 aces, 3 kings. The player chooses their first card and records the results, then chooses their second card without replacement and records the results. The player wins if they get a pair of aces, or theoretically you would play this with your friend. Obviously we don't have enough people, so we're not going to collect data as a group, but I'll give you data that I've pulled. Okay, so for instance, on this first card, we have ace, king, 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 ace, king, king, ace, king, ace. On the second card, we have king, ace, king, ace, king, ace, king, king, ace, ace. And then the question is, did they win? Remember, you can only win if you have both kings or both aces. So there's a win right here, there's a win right here, and then there's a win right here. So based on our 10 games, what's the probability of winning this game? Well, we won 3 out of 10 times, right? So that's going to be 0.3 or 30%. All right, so again, we would theoretically do this independently. Our class data would be 116/300, also known as 0.387, so about 38.7%. All right, so let's actually use a tree diagram to calculate the theoretical probability. So if you have the first card is pulled to be an ace, the probability of that happening, remember there's only 2 aces and then there's 3 kings. So the probability of that happening is going to be 2 out of 5. And that's the probability of first ace. And the probability of pulling the first card to be a king is going to be 3 out of 5 because there's 3 kings and there's 5 cards, right? So now we want to find out what's the probability of pulling out a ace after the first card is an ace. So let's think about it. First card is an ace, so that takes out one of the aces, right? So now we have 4 cards, and there's only 1 ace left. The probability that the second card is a king, remember there's still only 4 cards, but how many kings are there? 3. Down here at the bottom, if you pulled the first card as a king, then there's still 2 aces left over, but there's still 4 cards. If you pull out a king, then there's only 2 kings left over, and there's still 4 cards. Okay? So now they want us to do the probability of A and B. So the probability that you're going to get the first is an ace and the second is an ace. Okay? If you ever see this and, that means to multiply. I know on Monday we talked about or being add. Remember, and means to multiply. Okay? So we're going to take the probability that you pull the first as an ace, which was 2 out of 5, right? And we're going to multiply that by the second is an ace, which is 1 out of 4. And I know nobody likes multiplying fractions, but 2 times 1 is going to give us 2, and then 5 times 4 is going to give us 20. And yeah, you could simplify it, but you can leave it alone as well. On the next one, it says the probability the first card is an ace, which is 2 out of 5. And we're going to multiply by the second is a king, which is 3 out of 4. So when we're multiplying straight across, we get 6 out of 20. On the next one, we have the first is a king, which is 3 out of 5, multiplied by 2 out of 4. So we're going to get 6 out of 20. And on the last one, the first is a king, and the second is a king. That's going to give me 6 out of 20. Now the thought is, we find the theoretical probability of winning the game. We only win if we get both a pair of ace or a pair of kings. Okay? So the only way that that happens is if this happens or if this happens. So what we're going to do is we're going to take those two probabilities and we're going to add them together, right? So we've got 2 out of 20 plus 6 out of 20, which is going to give me 8 out of 20, also known as 0.4. Right? And so what is the probability that the first card was a king, given that the person won the game? Okay, so whenever you see this word given, I want you to think this is what's going to have to go on the bottom. So on the bottom of the fraction, we have this 0.4, right? Or this 8 out of 20. We're going to write it as a fraction first, and then we'll write it as a decimal. Okay, in the top, it says what's the probability of the first was a king. Okay, so given that the person won the game, okay, so the person won the game, what's the probability that the first is a king? Well, that's 6 out of 20, right? So that's going to give me 0.3 if I simplify it. So 0.3 divided by 0.4 is going to give us 0.75. So on the back, the big takeaways for today are the general multiplication rule, which says that the probability of A and B is equal to the probability of A times the probability of B given A. This is the conditional probability. We talked about this one on Monday. We also learned that if A and B are independent, then the probability of B given A is equal to probability of B. So P and A is equal to the probability of A times the probability of B. And then we talked about tree diagrams. So we always have the probability of A, and then we always have the probability of A not. And once we have those two branches, then we have the probability of B given A and the probability of C given A. Down here we've got the probability of B given A not and the probability of C A not. And so really what this boils down to is, and I know that's tough to read, the probability of A and B, the probability of A and C, the probability of A not and B, and the probability of A not and C. And whenever you do this, you can take up these probabilities, add them together, and they should equal 1. If they don't equal 1, you did something wrong.